Okay. Good afternoon. Good morning, or where are we now? Just about, yeah, good afternoon. Thanks for coming. My name is Bill Shetty, and today we're going to talk a little bit about application portability on Kubernetes. And there'll be three presenters, myself, and I've got two colleagues here, Dan Elson, who works with me, and Art Falwell, who is one of our technical product managers. Okay? So what are we going to cover today? Pretty simple. Going to go over some Kubernetes basics, talk a little bit about just what it means to do a deployment in Kubernetes, just to set everybody straight. What does portability mean, right? Just keep that really simple at high level, right? And then we're going to talk a little bit about how you deploy an application with respect to portability on a couple of different locations. One is on what we're using VMware PKS, one of VMware's products that lets you effectively deploy and manage Kubernetes on EC2, right, or vSphere, so you have consistency on both locations. And then a SaaS service that we also offer that lets you do the same, but actually manages that deployment and is a hassle-free way of actually bringing up clusters simply, and the only thing that has to really be managed is the deployment of the application. And we'll summarize and we'll take the Q&A. Sorry. Okay. So what's Kubernetes? Well, let's start with containers for a second, right? Containers are a self-contained application that can effectively run anywhere, right? It's got all those components that's necessary. It allows the developer to have an ability to really get application acceleration, right? Portability, right, from one location to another, and simplifies the deployment process. But managing those containers, right, and managing the deployment of those containers, right, is a little bit of a challenge. And this is where Kubernetes comes in. It's an orchestrator, right? It's going to allow you to effectively go and deploy that application based on memory, size of CPU, right, network, gives you the ability to effectively manage versions, right? Put tags in your application, allows you to restart and recover from issues and failures, gives you baseline abilities to install like monitoring, logging, and other capabilities for observability, right? And it also provides things like DNS-based services so that your applications, as they come up, the services that are there can find each other. So it sets up the network underneath and pins all that together, right? And it's a great orchestration tool, right? And it gives you an API that you can connect to, right? So, Kubernetes is fairly popular. Obviously, you have EKS, and from Amazon, and you probably are potentially running that even on-prem using a couple of other tools like Hops and some other baseline Kubernetes management tools. But let's talk a little bit about the application and what a Kubernetes application is first, right? There's several different components. The main component of the application is obviously, first of all, it's running on a cluster, right? A Kubernetes cluster, which is made up of several nodes, right? Or machines, could be virtual machines. And inside of those virtual machines, you're going to have what we call deployments or pods, right? And these pods are the components of your applications, right? In this example, we have a simple LAMP-based application that's got an API server, a website, and a MySQL component. And those pods get deployed, and each one of those pods has one or two different containers that are running on it, right? Generally one, and then you can add different components inside of it. And each set of pods, right, effectively, once you deploy that, let's say an API server as you're seeing here, if you deploy that, you can run multiple instances of that pod, effectively allowing you to scale automatically or manually, right, the size of that deployment. So if you have a lot of requests coming in, let's say to that API service from the outside, right? You can automatically, with Kubernetes, ask it to resize and scale that service. And what it would do is go in and increase the number of pods that you have automatically. Now, when you write a Kubernetes-based application, majority of this is going to be what we like to call stateless and ephemeral, right? And state's generally kept in one location. It's generally in the database tier. Hence, this is why you can do automated scaling like that. Now, those are the components that make up the application in the cluster. Now, in addition to this, you'll have different components that you'll install, such as an ingress controller. Think of it as a load balancer, right? You'll have components that help you manage security, right? Monitoring, like Prometheus, right? Or logging, like FluentBit. And those are bits that you add in, and I call them the non-application supporting components, right? And these constitute what you would basically go and deploy inside of a cluster. Maybe it's on EKS, could be on our PKS service, which we'll talk about in a minute. But this generally constitutes the different components that are there. And once I have this running, the beauty of utilizing Kubernetes and containers is that I can take that application in its entirety, the controllers, so the traffic management that I have, the application monitoring bits, and then all of the application components, those pods, the deployments, and reconstitute that in different locations, right? I can run it on EC2 using kops, which is an open source Kubernetes management tool. I can run it on EKS, or I can run it on-prem on vSphere with Pivotal Container Service, as an example, or wherever else you may think it's viable, right? So that's kind of portability, right, if we think about it. But how do we achieve this? And I think part of this is the fact that all of these services or locations where you instantiate that application are what we like to call Kubernetes conformant services. So as long as it's a Kubernetes conformant service, you're going to be able to take your YAMLs and that application deployment components and run that in any one of those locations. Now, that kind of addresses what we think of when we think of complete portability. Okay, I can take my application now and run it in different locations without really changing anything, okay? However, that's not the only bit, right? When we think of portability, we have to think of a few other components around this. And that's where it's not just about reconstituting the app, but it's about ensuring that as you go from one location to another, right, you have a simple, consistent way of scaling those resources that are there, right? So the example I gave you about scaling, let's say, the API service, right? That's done in a consistent fashion regardless of where you are, and the utilization of those resources is done consistently across any location. You also want to be able to manage those resources consistently and manage their cost, right, uniformly. And finally, you want to be able to actually manage some of that security, whether it's application-based or even giving users different access rights to the containers or the clusters specifically, and keep that consistent across your on-prem and in Amazon, right, locations. So that's what I think of when we talk about portability, right? In its complete picture, it's not just about app movement, but about all these other components around it. And today we'll talk a little bit about that, and we'll show you how VMware kind of helps provide this when trying to run applications on Kubernetes, both on-prem, right, whether it's on vSphere, or in Amazon on EC2. And we'll talk about how you achieve that consistency in two formats here. One is, right, using a tool called VMware PKS that effectively helps you self-manage that Kubernetes deployment automatically, right, and helps you manage that across both locations, or use our hassle-free cluster management SaaS service called VMware Cloud PKS, right? And we'll give you a demo on both. So I'm going to hand it over here to Art, who's going to talk about VMware PKS.
Great. Thank you, Bill. How's everybody doing? I'm just going to go ahead, let's see, and oops, one backwards instead of forwards here. I'm going to build this slide out so I can speak to it as a whole rather than going through the animations. So as Bill mentioned, we have a couple different ways that you can choose to consume PKS. If you prefer accessing the cloud service, go into a browser, maybe swipe a credit card, and just say, I want to access Kubernetes. And then you're just given, here's the IP address to go connect to your Kubernetes cluster, right? That standard cloud provider type of service, that's the Cloud PKS. And what I'm talking about is a different version of PKS. It can run in the cloud, it can run on your premise, but it's a version that you install yourself, right? And so why do I want to potentially install PKS myself? Because in some cases I do, some cases I don't. But usually, quite often, what we find is enterprise IT departments are being asked to support containerization service. So when our consumers come and ask us, hey, we've got a containerized workload, we've got some new cool stuff we're working on, we can provide those consumers the environment that they need to be productive, right? And Kubernetes is the way to really operationalize container deployments in an enterprise setting. Now, what if rather than sending your users to a cloud provider service where you still have administrative control, right, and you can define policies of what they can and can't access to the cloud service, maybe you want to run your own service. Maybe you want to host a service that, like, for example, when I go to Amazon's Elastic Kubernetes service, if I go to Cloud PKS, if I go to Google or Azure's Kubernetes service, what they do is they create a Kubernetes cluster. Right, which is a Kubernetes orchestrator, a master node, and then has some worker nodes. And so in that context, when I run a containerized application, I'm not going to say, I'm going to go put a container on server 2. I'm going to say, hey, Kubernetes master node, will you go make sure these containers are running for me? And it goes and puts those on the worker nodes for me. So what's a master node and what's a worker node, right? It's just a virtual machine or a physical machine with some Linux and a Docker type agent on it that has the Kubernetes software installed on it for you, right? And so when you go to one of these Kubernetes services, Amazon's Kubernetes, what have you, and you say, I want to use Kubernetes. Maybe your consumers are used to going to a cloud provider, and you want to provide as an IT department that same experience. Right? So they go to a portal and they say, give me a Kubernetes cluster, and Amazon will give them a Kubernetes cluster, right? It's just like if you come to Cloud PKS. But in this case where you install it yourself, you get the driver's seat. You own the API server. You own the server where that user can either directly make an API call, or if you can have a service catalog, have that user go in, and what this service will do is this will then create the Kubernetes clusters on demand. So making you essentially the service provider of your Kubernetes service for your end users. Right? And it's all built in and in a nice, easily installable and supportable package provided by VMware. And you can install this package on your local vSphere environment. You can install it into Amazon EC2. I've got an instance that's running on EC2. And let's see if my pointer can. I don't think my pointer really displays over there very well now. But what we have at the very top where you see API, PKS control plane, so that's a virtual machine. So it's a virtual machine that provides an API that I can call, and with a command, like on the command line, I would say PKS create cluster and give it the name of a cluster. And it just goes and creates a new Kubernetes cluster for you. Right? And so I interact with that API. It's just a virtual machine. And you don't even have to install that virtual machine. It gets installed automatically. The installation process for this is largely automatic. Right? Then there you have something called BOSH. Right? BOSH is an underlying system that we have embedded in PCS here. It's an open source platform. And what it does is it does the installation. It takes, when you say, I want a new cluster, it's going to go out and it's going to take Kubernetes master software. It's going to take Kubernetes worker software. It's going to build a new virtual machine from scratch, and it's going to do a brand new, fresh, clean install for you on demand. So I say PKS create cluster. It's going to go, that call will go into the API. And the API will go reach out to BOSH and say, hey, BOSH, we got a new cluster that's created that we have requested created. And it goes out and it talks to EC2 over there on the right. And it's going to interact with the EC2 APIs. And so there's a little example of my command, PKS create cluster, give it the name of the cluster. And I keep going backwards instead of forwards on this thing. And then over there on the right-hand side, you see those boxes, and those boxes represent my Kubernetes worker nodes. Right? And so what this looks like when we look at it in our EC2 is on the left here, we have a couple virtual machines we'll see in EC2. On the right, we have a couple virtual machines. And so when you look in your EC2 console, you can look at the virtual machines like you normally do. You can do everything you normally do to support some application that you're helping to support, making sure that virtual infrastructure is all running right, and do the same troubleshooting commands that you have on your virtualized infrastructure to be able to support that. Right? And typically, when you have a trouble call in an enterprise environment, not everybody knows the details of the app that's running on the virtual machine that you're troubleshooting, right? So not everybody needs to be the Kubernetes expert to be able to help support this environment. If you supported any application on virtual machines before, your skill sets are relevant here to be able to help support this application. Right? And so that's essentially how it works in a nutshell. You do an initial installation of a Terraform script. It goes and installs on the left-hand side. That's our control plane, right? So the BOSH and the PKS API. And that stays there, and then we call that system every time someone wants a new cluster. So a user opens a help desk ticket, maybe they go to a self-service catalog, and they say, hey, I need a new cluster, and they get an experience that is essentially very, very close, almost identical to when they go to a service provider. And so this product, I think, really allows enterprise IT to deliver these cloud-native and Kubernetes services to their consumers in a very simple way, much like they would have, and the consumer gets the same type of experience that they would get if they went to a leading cloud provider, right? And you can install this on your AWS environment quite easily with some Terraform scripts that we provide right in the documentation. And so this is not my laptop, so the demo is a little different than what I had planned on my own laptop, but let me see if I can figure this out here. We'll go over to Chrome. Oh, wait, I'm not mirrored, so I cannot really see what I'm doing over there. So this is going to be a little rough, but you can see that I have 12 running instances, and you can see this better than I can right now. Now I'm going to walk over here a little closer to my screen so I can see this a little better. And just to give you a little bit of my experience here, I'm new to AWS, so I'm having a lot of the experience I think a lot of you probably did. I've dabbled with my free tier account, but I just recently got my full account, and actually really to get set up for this demo. So I'm pretty new to everything, and I just went to our documentation and ran through the Terraform script. And it just asks you for the access key. And the Terraform script that we provide is actually really cool. It goes and creates, there's a number of different networks, front-end networks, load balancer networks, back-end networks, networks for different infrastructure network and management network. It creates all of those for you all automatically and just gives you back the information. Creates the security groups, puts everything in an appropriate security group. It creates several different routing tables for you all automatically, right? And it puts the appropriate subnets into the appropriate routing table, so when you deploy PKS on AWS, you run that Terraform script, and the result of the installation is you get all the VMs, right? There was one virtual machine that I installed. Right? And everything else you see here, the control plane gets installed by the Terraform script. And after you do the control plane, and after you get the control plane installed, you just log into PKS. And you say, PKS create cluster my cluster. And let's see, I should have that up here on the command line. I can't see the command line either because I'm not mirrored. So I think I have the commands right here. So this is my command for PKS login. And you can see I am now logged into that PKS endpoint, and I can do like PKS clusters. And, oops, I cannot see. I'm capitalizing, aren't I? I apologize. I can't really see my commands over here. There we are. And so I have a cluster running right now. This is a medium-sized cluster. And if my demo, if I was on my own laptop, I could make this a little more vivid. But this cluster I created that has 3 master nodes. So high availability master nodes. It's running across 3 AWS availability zones: US East 1, US East 2A, 2B, and 2C. And yeah, I just went in and used the command PKS create cluster. And a few minutes later, comes back with a running cluster for you, and you can just provide this endpoint information to your end user. So when you get a request from a user, they want you to provision, and because you've installed this version yourself, you have complete control over the policies that you choose. And that's one of the reasons why you might choose an install yourself over just going to a native cloud service, is it does give you more administrative control about the amount of policy that you do put in and so on. So I think that's about it for me. Hopefully that was useful for everybody, and I'll go ahead and hand the ball back to Bill. Thanks, Bill.
Okay, thanks, Art. So that was a quick walkthrough of VMware PKS. And obviously, just as a summary, right, I think what you can see here is that, VMware PKS allows you to effectively deploy Kubernetes with a significant amount of components and configuration components, plus add-ons, right, like managing your network, actually deploying and managing Kubernetes different versions. And you can do that on as Art talked about, and he showed, he's running it on EC2, but you can also run that on vSphere. And it keeps and provides you with a consistency between both locations. So you can then have the additional portability components that I talked about in both areas, security, scaling, et cetera. So let me just get through this. So that was VMware PKS. So now let's talk a little bit about our second offering, which is VMware Cloud PKS. And VMware Cloud PKS is a SaaS-based service. What that means is you effectively come to VMware, this location, VMware, cloud.vmware.com, log in, put your credit card in, and you get access to the service that allows you to effectively point it to different Amazon locations, right, or regions. And almost instantaneously from that, and we'll show you a demo, right, within 2 to 3 steps, launch a cluster that the service manages for you and then gives you access to the cluster where you can go in and deploy an application, right? And it's a completely, fully certified Kubernetes conformance service. It has full integration into any and all of your Amazon services, right? We'll talk about that in a minute. And it's got multiple locations on Amazon around the world. So there's several different benefits here, right, of this service. One of them is what we like to call Smart Cluster, right? And what VMware Smart Cluster technology is that once you go deploy that cluster, the service actually goes and determines what the capacity needs to be for that cluster. You never put in a capacity amount, right? So let's say EKS or even on-prem, you would have to go in and say, I need this many nodes of maybe large or small size or maybe with a certain CPU, and you bring that up. In VMware Cloud PKS, you effectively say, I just want to create a cluster. Once that cluster is created, depending on how you actually deploy your application, let's say kubectl, create, it will detect how much capacity is required, spin up the required number of worker nodes for you automatically, and then do the deployment. And then let's say you take out some of those pieces of the application. It will determine that the resources have gone down, and it'll take those worker nodes away. So what does this do for you with respect to Amazon? It's going to save you money, and it's going to be managing those costs on EC2, specifically around the utilization of those instances that are running Kubernetes, right? And you never have to worry about it, right? So it scales up and scales down automatically without you ever having to touch it, whether you're a developer or an admin. And it has high availability built in. So it'll actually do a deployment across multiple availability zones for you, right, in addition. And it effectively optimizes those resources that it's deploying on. That's a pretty great feature, and we'll show you how that works in the demo. So that's one of the good features that we have on VMware Cloud PKS. Another one is the fact that it's got global reach, right? It has accessibility on multiple locations, and we're bringing up more regions on a regular basis. Today we've got Ireland, US West, which is Oregon, and we've got Virginia, right, US East region, and I think we're bringing up Tokyo fairly soon. And those will keep increasing over time. Now, just like any other Kubernetes-based service, right, VMware Cloud PKS is fully conformant, right? And what does that mean? That means that any application component or any sort of plugin that you find in the ecosystem, right, you can use as is with no modifications on VMware Cloud PKS. So, I don't know, let's say you find some specific component that you like out there on the web, follow the instructions as is, load it up, right, no modifications to the service, to the cluster, or to the installation instructions, right? It's fully conformant, right? And that is great because now you have an ability to install any of those pieces that you need natively on your cluster, right, which is running on Amazon. And of course, you can use other pieces and other services, and I'll talk about that in a minute, but you can also connect it up to the broad ecosystem of management components, right, that are out there like Splunk, or you can connect it up to like our service called Wavefront that helps you do monitoring, et cetera. Now, it also gives you seamless access to Amazon services. What that means is, let's say I go deploy that 3-tiered app that I talked about a little earlier, right? With an API server, a web server, and then a MySQL component. Well, suppose I wanted to replace that MySQL component with RDS. I can do that very easily, right? The cluster actually will connect, right, to another RDS location that may be in another VPC, with a VPC peering connection, right? It can use an endpoint location and connect up to DynamoDB or other locations for you so that you would have connectivity between those application components that are running inside of that cluster. In my instance, there would be the Flask server, or let's say the Django server that's running, connect directly to the database where the information is being stored, all right? So once you create that cluster, you have an ability to go in and connect to any other services that you need automatically, right? And again, right, this service is helping you manage the cluster itself. So you don't have any issues about managing that cluster. In addition, the deployment of these clusters, right, is actually a multi-tenant framework. What that means is when you come in and we deploy these clusters for you on Amazon, right, every single customer gets their own set of full instantiation, right, of identity management, policy management, and all the multiple smart cluster components that come up and bring those pieces up, including network services. And everything is separated and segregated logically for you. And of course, the more important piece and the final piece here, I think is a very important feature and capability here is what we call the policy framework. One of the things around managing, let's say, a cluster or a set of clusters between hybrid or on-prem and on Amazon is how do we give access to what component and who do we give access to? So one of the things that we've developed inside of this service is this policy framework that's a hierarchical policy management framework. What that allows you to do is to set up different projects within an organization, right? Set up different folders and projects, and the clusters are attached to those projects. And allows you to segment out access to individual clusters by either a project, right, or a folder, and whatever you want to call that folder. So let's say finance has something that has to be deployed, and it's going to use Kubernetes. But you know that the development team, right, is running on a specific project to do the development, and only they will have access to do this. But you can say that underneath the folder on that project, that's the development team. And you can have another project which could maybe be the production deployment component. And that can get access to, let's say, just the DevOps guys who need access to it from a management perspective once it's fully deployed, and you don't want the developer team to actually get access to that. And so we do strict access between those two projects. And so this gives you a really, really rich policy management framework and security for your clusters across multiple locations, multiple regions, right, and multiple clouds, right, on-prem or on the Amazon. And so those are some of the features and capabilities that are on VMware Cloud PKS. So now we'll go into a demo, and we'll show you how easy it is to actually use and deploy an application and work through some of those features that I just talked about.
Thanks, Bill. All right. So I'm going to bounce out of this real quick so that I can see what I'm doing, because otherwise we're going to have real problems. So as Bill mentioned, we do access all of our cloud services here at VMware off of our cloud services console. So that's off of our cloud.vmware.com website. Any of these services, you guys can go to that website. There's information about the service, how to request access, all that lovely stuff that any good SaaS-delivered service in the modern era has. But specifically, we're going to look at Cloud PKS today. So I'm going to bounce back into the dashboard for this service. Okay? So here's what I'm confronted with from the first time I log into Cloud PKS. Now, obviously, I've been in here a couple times because there's some objects in the inventory over there. But the first thing we always look at is how easy is it for me to build my first cluster, get into it, and start doing things. So we're going to find out very literally in a very fun and live manner, right? So Cloud PKS gives me a way to build a Kubernetes cluster with 3 parameters. I need to pick if I want a development or production cluster. Okay? Difference is how resilient that cluster is going to be, how many availability zones it's spread over, and whether it gets strict VPC isolation or not. I got to pick a region, and I have to give it a name. So we're West, we'll stick with West, and we will call this the always fate-tempting live demo. Ready? And that's it. So that kicks off a new Kubernetes cluster build in Cloud PKS. So that's going to run for a minute. Typical time on this development cluster, about 3.5 to 4 minutes, depending on how quickly elastic load balancers are resolving DNS names today. But what we're going to do right now is I'm going to, what we affectionately refer to as Martha Stewart this thing, and I'm going to skip to a cluster I already built that I called reInvent. Okay? So this is the same development cluster, same config, just a different name. Okay? What we see when we log into one of these clusters, it has no compute resources because this cluster built a control and management plane. Okay? I haven't given it anything to do yet. It has no reason to have built any worker nodes. However, I can give it something to do. And so just as Art did here, I am going to use the CLI package. And I can actually go back through my history here. And what this is doing, this goes out, it looks at the Cloud PKS service API endpoint that I'm already authenticated to. It gets the list of objects that I have permissions for and that my user is entitled to look at, right? Once I look at that, it takes the cluster name that I have fed it, it looks in the inventory for it, and it merges my kube control credentials on my machine against the certificate for that cluster, right? So that's kind of what's happened in that one CLI command behind the scenes. So from here, it's kubectl just like everywhere else in the world, right? If I get nodes, I should see one node, right? I don't have any workers. I'm running single master in a development cluster. So I have exactly what I'd expect. And if I run get pods, I should see nothing. Okay? Now, just for fun, okay, I'm going to run Helm init. Helm init's going to kick off a tiller deploy. Tiller has to be deployed somewhere. I have no worker nodes. So what should happen from here is my cluster should go out and build a worker node to accommodate tiller for me. Okay? And I'll actually see that if I do a get pods on kube system. Okay? So there's tiller, 0 of 1, it's pending, meaning this thing is going to try to deploy, it doesn't have a node to deploy on right now. And if I can remember how to type words today, I can do a get nodes wait with the -w option. So what you'll see right now is the master. What's going on in the background is our auto-scaling logic is actually sitting there figuring out, okay, how big is that pod? What's that manifest look like that I'm trying to deploy? How big is that pod? How many resources will I need? How many worker nodes does that equate to? And it's doing that logic. So we'll see the masters. What will happen here in a minute is it'll actually start to pick up the build of the worker node as the worker node comes online and joins the cluster. Now, I'm going to switch back to the UI for a second, but we're going to leave that run and we're going to come back to it, okay? As Bill mentioned, you know, the object hierarchy, and we can actually see my cluster build from before is still going on. As Bill mentioned before, right, the object hierarchy is one of the things we look at in terms of running a multi-cluster, multi-region service for Kubernetes. So we're going to come into that policy language real quick, and I'm actually going to look at the smart cluster that I've been dealing with here today. Right? So because of the way the organizational stack works, we've got direct policy, stuff I said I want this cluster to behave like X, and I've got inherited policy where the projects, folders, and organization level of the hierarchy on top of that, I've set policy there, that should cascade down, right? If I made Bill a project admin on the project that holds this cluster, right, we should see him get that permission inside of the cluster, right? And so these are the inherited policies that you'll see here. Now, these are being done against groups. These are system groups. I can make my own groups. I can do individual users. Or I could directly set policy here. I don't have any policy binding set because I just made this cluster empty. Okay? And again, I've got cluster, project, folder, and organization, which for us is the same as service tenant. If I want to set an actual permission, there's one other level. There's actually an individual namespace permission that I can set inside of the cluster from here, right? So I could give Art permission to one namespace on all my Kubernetes clusters across a project or a folder with one statement, instead of having to go into each cluster and manually deal with Kubernetes RBAC and all the fun management that comes with that. So in the meantime, I'm going to flip back, and if we look, I'm going to Control-C out of this now because we don't need to wait, we can actually see where my worker node picked up, right? And if I go back and I run my get pods again, we can see that my tiller is running there. And from here, I can run literally any Helm chart off of the stable repos I want, right? So I could do a Helm install. I could do stable WordPress, for example. And it's going to go out, look at the repo, grab WordPress, set up the 2 pods, and go and build, right? And I've gotten the always fun deployment name, Virulent Poodle. That's fun even for today. Couldn't have planned that better myself. But if I run my get pods, we'll see those go into container creating. They'll come up as one would expect. There's usually a little lag here while we wait on MariaDB. But again, this is not stuff I've had to customize. I could do this exactly the same on Cloud PKS as I could do on PKS, as I could do on EKS or anywhere else, right? The idea here is using that Kubernetes abstraction point as the portability point to let me say, I don't really fundamentally care what infrastructure domain I have to deal in. I want this application to run. I want it to run according to spec, and I want a common spec that allows me to pick up and go. Okay. So with that, that was our fun demonstration portion. It literally is that easy, and actually, just for fun, since I'm here, while we were doing all this, the always popular live demo cluster is up and ready to go. So in the couple of minutes I was talking about other things, I have a brand new Kubernetes cluster that I could log into with that same credentials merge command and do whatever I wanted with, right? Sub 5 minutes. Okay. So from here, again, just a little bit of summarization on some of the benefits here for the Cloud PKS service. we kind of break it down into two domains, right? A developer domain where we say, look, for a developer, you can get into this thing in only a few minutes, get a brand new cluster that's yours to do whatever you want with. You can use the connections or networking service that Bill alluded to earlier to get out and connect to other native Amazon services, your existing VPCs in other accounts in other regions, whatever you need to do from connectivity there, and all your standard tooling. From an administrative perspective, which developers have had a bunch of ways to do this for a while. From an administrative perspective, it is about having a multi-region, multi-cluster service, meaning I'm not managing one cluster at a time, one cluster's credentials and RBAC at a time. I'm managing the full set, and I'm managing with a consistent policy layer across that, right? It allows me to do really simplified management from one interface. And because of the smart cluster autoscaling technology, I'm not building a cluster with 5, 7, 10 worker nodes, and then finding out later I'm really only using the equivalent of 2 or 3 of them, right? It's scaling out based on what I request. Oh, and by the way, it's monitoring, and if I turn down a namespace and the stuff associated with it, it will turn down the worker nodes for me after a bit of a lag period. So it does wait a little while to make sure you meant it when you deleted all that stuff and weren't just going to re-provision it, but it does scale back in on the worker node count as well. Whole idea is those resources just cost you money. If we don't need them, let's pull back on them and save you guys some money while we're at it. Okay? So I believe we have about 15 minutes left in our session here. So Bill, Art, if you guys want to come back up, and then if anybody has any questions, we'd be happy to take them.
Yeah, thanks.
There's a microphone here. There's a gentleman waving a microphone in the back of the room. So if anybody really wants to ask a question, I don't know, maybe raise your hand or.
I see one over here. I'm going to shout it out and repeat it up here.
Sure. Just in general, when using microservices like Kubernetes, it works very well for stateless. What would you do for something stateful like a database where obviously the network shut things down, you want it to persist? What kind of solutions do you guys usually like to use for that?
So do you want me to? You want to do that?
Sure. So. So there's a lot of ways to skin that cat, right? So you can deploy a database inside a Kubernetes cluster if you want to. I would argue it's maybe not the optimal way to do it. Database services a la RDS seem to be a very favorable way to do that and use that as an external connection point from a data perspective. With our connections feature, we can get to that via the private networking without having to transit internet gateways or things like that if you're worried about data security and the path that data is taking. So that's one way to deal with the database side. From a stateful data that doesn't necessarily go into a database, you have the persistent volume and persistent volume claim function inside Kubernetes, where it's actually deploying a volume disk that's mounted onto a container and then storing the data there. Like anybody else that rides on AWS infrastructure, we're using EBS volumes as that persistent data store. Once you have those volumes, we do them with dynamic provisioning, so we're using the persistent volume claim mechanism inside of Kubernetes to do that. We're adding support for statically provisioned volumes as well in the future. With statically provisioned volumes, you get a couple more options in terms of what the reclamation strategy is for that volume when the pod that it's attached to goes away. Does it stay? Does it persist even after the pod dies? Does it get recycled with the pod? Things like that. With more statically defined persistent volumes, that would give you some options to then go out via the backend connectivity and dump the contents of that volume into an S3 bucket or some other storage provider of your choice. Now that's the data side. There's a whole another line of thought on the actual containers and pod side around using things like stateful sets in Kubernetes to give some ordinal numbering to your individual containers and pods to give you some order to that whole process, and that's probably at least a 90-minute talk by itself. But most frequently, when I get that question, it's a data question, but there is also a compute runtime aspect to that question, which is where stateful sets and those kind of constructs in Kubernetes come into play. Yes, sir.
Question, so you said you can connect to RDS from the cluster, but are you also including operators so I can go deploy RDS directly from using CRE or something like
Okay, so the question was, we can connect to RDS from inside the cluster. We mentioned that, but do we allow for, or do we have a good method for the creation of like an RDS instance using a custom resource in Kubernetes? We don't have one baked into the service, but again, as long as the Kubernetes API version of the clusters we're using, in this case, I think the cluster I was using today was 1.10.8. As long as that supports it, there's no reason you couldn't go then define it and ask for it. Now, with custom resource stuff, you may have seen on the screen there was a flag for privileged mode. You would almost certainly need privileged mode to do that sort of behavior, but no, we don't have one defined today to do that, but if you wanted to attempt to define one within your cluster, that would be something you could do if you have the logic for it.
Yeah, you got another one there. Go ahead.
Oh, sorry.
We're going to come back, please, we're going to come back to this fellow, though, because I know we're not looking his direction right now.
Go ahead.
Okay, a question. You showed how to create a cluster. The question is then, how do you maintain it? Maintaining two things. For one, upgrading the database, and two, maintaining the versions as well.
Yeah, go back.
Because you need to apply patches and such. How do you do that?
Yes, so, yeah, go ahead.
Go ahead.
No, you can go ahead. So
Okay.
he's going to show you how we actually.
I need to find an older cluster. Give me just a moment.
The cluster itself obviously manages
Bill,
components and stuff.
Can we repeat the question? Because some other folks in
Yes,
the room
so
probably didn't hear it.
The question is, how do we actually manage and maintain the cluster, right? From a size resource perspective and also from a upgrade and a maintenance perspective, right? Go ahead and go through the. We'll just show you an example here.
So I found a slightly older cluster that's running on 110.2. So again, because we're running a fully managed service, we keep a few different versions of Kubernetes kind of in our repertoire at any point in time. So I can actually do a point and click from the menu upgrade of Kubernetes, right? So it's going to start with the master, and then it's going to roll the update through all the workers sequentially, one at a time, right? So that's how we handle the cluster updating operation. And then I think you had asked about patching and other things as well from the actual application.
The nodes, right?
Right, so yes, we are deploying EC2 nodes. So there's a couple ways to handle that strategy, right? The thing with the EC2 nodes is they're going to persist as long as something is scheduled on top of them. So there's a couple different operational ways to think about this. You don't have access to the nodes directly, and that's part of running a fully managed service, right? So you can't necessarily manually say, I want to update the 4 worker nodes that I know make up this cluster. What you can do is by running a Kubernetes by running a cluster update here, we're going to go through an update to our newer builds of the worker nodes. So you should pick up incremental over time EC2 updates along the way. The other option you have is to essentially take the Kubernetes YAML definitions, dump them, empty out the cluster, which will kill off all the workers, right? It's kind of operationally a complex thing that doesn't make a lot of sense. Honestly, what I would do if I wanted to do that, I would build a brand new cluster in the service that I know is going to pick up all the newest, latest, and greatest updates anyway. I would dump the running YAMLs from another cluster and rerun them against the new cluster and then just kill the old one. Right? Honestly, I don't think it makes sense to go through the operational churn of trying to dump them out and make sure they get updated that way and things like that. Yes, sir.
How do you manage key management? So, for example, for authentication to different types of services or apps that you want to be able to connect to, do you recommend a certificate authority? Such as using PKI? Do you recommend a hardware security module for key management in order to do dynamic key management? What is the recommendation?
Okay, so the question, in case anyone didn't hear it, is what do you recommend for key management and credential management, these sort of things? Right, so first and foremost, I recommend you do whatever your security department tells you is required of you.
Basically.
I have to say this because if I don't, I will undoubtedly get yelled at. Now, beyond that, right, so we are providing Kubernetes clusters as a service, first and foremost, right? So how you want to manage authentication is up to you. I'll tell you how I look at the problem. I look at it from a perspective of I want something like Vault, for example. As a credential manager for me, it allows me to manage credentials for multiple clusters, multiple different applications. It allows me a really simple, easy interface to deal with that. I can actually get to it. I can run it in my own space. I can get to it very easily through the back-end connections without necessarily having to transit the internet. It's a nice way that I like to do it. But that's a very personal thing. We don't generally give a boilerplate recommendation for here's how you should do credentialing and authentication against your own resources. In terms of our clusters, we have a back-end system that's handling the certificate exchange and credentialing that relates to building and accessing the clusters with the users in our system. We have our back-end that deals with that and that alone. That's CA per tenant organization, essentially, across the system. But in terms of how you want to do it, personally, I think Vault's a great solution for that. I really like it. Some folks will tell you that if you really want to be very, very sure and very secure, that you should look at things like hardware modules. I use some personally. We don't necessarily use them from a VMware corporate context. So, look at the requirement, what it is, because everybody's going to have a slightly different requirement in terms of how that looks.
Because I asked the PKS program manager over a year ago, and he didn't know. I used to work for EMC, so I know he wasn't able to answer any of the
But this,
There wasn't a PKS program really over a year ago. It is a relatively new platform, so apologies if they didn't have the answer at the time, but it is an available product now.
you tried to deploy a what?
He tried to deploy a pod. He tried to deploy a pod.
Yes.
The VMware has automatically fired up a new node. So how does the auto-scaling work? It's given by VMware by default, or
I'm not sure. So the question is, how do we handle scaling?
exactly? How does the nodes pop up? Like, do you use any open source deployment inside the cluster, or VMware has it by default?
I think if you look at the cluster and you think about what you're deploying, there's generally a manifest or some general average size that gets utilized, right? If it hasn't been defined, so let's take the easy case of actually a defined one, right? If you've defined that inside of your YAML file, we know how much is required, right? So you round up to the latest one, and then you figure out what that node size has to be. Or there could already be a component that's already running and there's excess capacity, so we'll just fill that in, right? So you can manage the efficiency of that cluster. Now, if there's nothing running, like in the case that he showed where there's absolutely nothing, we bring up a standard node, right, worker node for the first time that gives you a certain amount of baseline capacity that starts up. And then it starts growing from there. We'll add more as needed, or until that gets more efficient, then we add another one, right? If there's less, and it just keeps growing from there.
And all the nodes which get fired up will be of the same size, or
It will be of the same size right now. We're working on trying to vary that for efficiencies for maybe, questions will come up about high performance computing or something to that effect, sure, right? But right now it's a predefined size, that's why it's a managed service. But and I think the way you think about this is that it is a scheduler. It's this massive scheduler that we've developed, right? That's on top of the Kubernetes scheduler. And it's going to start looking at different components because you would be able to, at some point, as this service grows, put in costs and other SLAs. So it could automatically pick, let's say, a specific node size that you need, right? Right now it's predefined. And that allows you to save money in a totally different way and to have optimization from a resource utilization perspective, right?
I know there was another question over here earlier. Is there still one? Did we get that already? You got it? Cool. Did you have one?
Yeah,
I tried to ask, you showed some roles and permissions
yeah.
inside the ESK. Is it meant to native Kubernetes role-based access control, or is it some extension?
Yeah, so the question is, we showed roles and policies. He's flipping through it right now. So the roles and policies that we talked about on top of this are really outside of Kubernetes, right? And what they're generally built for, right? Now, they're built for access to multi-cluster. So this is like if you use IAM policies right now, right, in Amazon, very similar to that. But it gives you a little bit more of a structured approach to kind of managing that security, right, and that policy across multiple clusters. Now, if you think about this across, let's say, a on-prem and a EC2 instance, this will give you that consistency across both locations, right? And or if you're running it across, multiple regions, et cetera, in one shot. So they don't percolate down, right? If what you're asking, and can I pick these up from a roles perspective, right? But
there's two levels, right? So there's the project folder organization hierarchy, which is super cluster hierarchy. That obviously, inside a cluster, you're not going to see any of those. Those are super cluster levels of the hierarchy. The cluster permissions you won't necessarily see either because it governs access to the cluster. So within the cluster, it doesn't necessarily make sense. If you set the namespace permissions, those actually do have to get translated into native Kubernetes RBAC. Otherwise, we could do it in another way, but that's really intensive and sort of unnecessary, right? When there's already a language and a policy framework there to use. So for our namespace controls, which you can kind of see from the dropdown there, we actually do translate that into native Kubernetes RBAC. But the cluster level and up, those are cluster or higher order constructs that won't, within a cluster, so within a Kubernetes API instance, there's no reason for those to exist, right? They have no bearing there, they have no relevance.
Maybe one llast question.
In terms of PKS for vSphere or EC2, are there any restrictions on the network overlays that are supported?
When it's running on EC2, I'm not certain actually. I know the documentation. So the AWS native implementation is newer for us. So it's as of right now, the documentation is entirely around running the Terraform scripts, and so I think it's as we. I don't have the background in that to know, the low-level details of what could be swapped out in there. The standard install leverages the native AWS constructs for networking, so it builds your VPC, builds your subnets, your route tables, and so on.
The network overlay within Kubernetes.
Oh, with, let's say Flannel or what have you. So yes, so I know on AWS, the standard is to leverage Flannel. And I'm not, forgive me, it being a new thing for me, I'm not certain on the AWS implementation if you can implement. Typically with PKS, you do have some ability to leverage the different network plugins. However, sometimes because Bosch is bootstrapping your Kubernetes nodes for you, it may require for you to do some work in Bosch to be able to implement an alternative network overlay. So Flannel on AWS, and Flannel really anywhere you install PKS. And we also, when you do install it on vSphere environments, you have the option for NSXT as well.
But as long as we're hitting a CNI conformant overlay, Bosch may struggle with it a little bit, but from an orchestration perspective, but as long as we're hitting fundamentally a CNI interface, we shouldn't have, from a running cluster perspective, we shouldn't have.
It's strictly, there's nothing about, Bosch really builds native Kubernetes clusters. And it's whether it's Bosch or anything else, it's if you are going to have some automation system that builds your Kubernetes cluster, that's going to watch your master nodes, so when your master node dies, it can rebuild it for you or fix it, right? Then you're going to have to get back in that automation system if you want your build for your, and so we have a framework within Bosch that for, if you need to get in and do some plug-in work to make, it, when it bootstraps it, right, to allow that to happen. So it should be fine. I don't want to, don't quote me on it yet, because generally we don't put any restrictions on the Kubernetes, with the one exception that if it does have to be something that's bootstrapped, we got to make sure we work with you to, if you're somebody who doesn't really know, how to mess with Bosch, you might have to work with our professional services. If you do know, if you have an experienced background, you can come in and set up in Bosch, then we'll just approve it, and you'll be able to run with really anything you want to do to the Kubernetes cluster.
Okay. Thank you. So I think that's it for today. You guys will still be around for a little bit if you have any other questions, but thank you.
Thanks, everybody.